Shall we start? Sir? Sir? Good evening to one and all present here. Welcome all to the Day 2 Session 4 of ATAL sponsored 6 days online faculty development program on recent trends and advancements in integrated power systems. I am delighted to introduce our guest resource person, here Annamalai Ramanathan, Director, Kronos Imaging Indian Private Limited, who is having 23 years of experience in new product development technology, intensive product platform creation, and new process establishment with proven execution skills. He has more experience across different domains like healthcare, semiconductor, and automobile industries. He has a proven track record in delivering business goals on time by collaborating with global across functional teams. He has proved his ability to successfully work for business success in multicultural environment. He began his career at Lucas TVS, where he worked as an electronics engineer for 2 years. Later, he advanced to GE Healthcare as a senior hardware engineering, contributing significantly to subsystem design. During his period, he successfully designed, developed, and integrated the 10L probe LOGIO3 pivotal achievement that resulted in market expansion of the product line. After that, he joined as a senior electric design engineer at KLA Tencor in Chennai, where he excelled in system integration. In subsequent role of GE Healthcare in Bangalore, he served as a lead in system design. In his leadership and technical expertise were instrumental delivering MX80 X-ray tube design by overcoming critical technology challenges, a project that resulted in significant $4 million value creation project for business. Later, he served as a program manager at Brilliant Factory and then as a segment leader PMO at Science Limited for 2 years. Now, presently, Sir is a director in Kronos Imaging India. Under his leadership, they demonstrated expertise in collaborating with the US entity to drive new product and development process improvements and cost reduction initiatives, identifying and nurturing customer relationship, enabling business growth, researching and leveraging growth opportunities for new business expansion, executive comprehensive growth roadmaps and strategies, managing budgets effectively to ensure operational success, building a robust supply chain by engaging and establishing strong partnership with vendors and suppliers, hiring and training employees to build skilled and efficient workplace. With extensive experience in hardware design, system integration, and leadership, our resource person has consistently delivered innovation solutions and business value throughout his career. His exceptional contribution make him an invaluable asset, and we are privileged to have him to share his insight and expertise with us today. Welcome you, sir.
Thank you, madam. It was a pretty lengthy introduction, but anyway, you've taken a lot of effort to introduce me, and I'm very happy to meet many of you here. I'm sure you guys are creating the next generation people for the industry. First of all, I would like to thank every one of you contributing to that cause. It is invaluable, and any number of thanks or anything we say, it cannot match the words. Thank you, all the professors, teachers, and other support staff who are making it happening every day. Thank you very much for that. And just one addition to it, now I'm also handling another company called Edify Engineering Solutions. And we have a client called Energy Vault, who is into gravity energy storage. And today's session is we are going to talk about gravity energy storage solution in specific. So with that, I would like to start my presentation. And I want this conversation to be two ways, and I don't want to just presenting what we are doing or what we are currently engaged with. I would like you guys to ask questions. In case if I know the answers, I will reply immediately. In case if I do not know, I can always connect with Jay Lakshmi or Illam Purnan or Anita, and give you the answer over email. So with that, can we start?
Yes, sir, you can start, sir.
Okay. So I'm going to share my screen and then let's walk through that.
Slideshow.
So we're going to talk about energy storage solution. Can I ask you what are the different types of energy storage available today? I would like to hear from you first. What are the different types of energy storage that is very popular today?
Battery.
Battery, excellent. Then, so I also want to reiterate there are two things. One is power generation, other one is energy generation, other one is energy storage. And this session is going to be completely with energy storage and not generation. And one is battery, excellent. What are the other two or three methods, common methods where we can store energy? Okay, so
Supercapacitor.
what is that?
Supercapacitors.
Supercapacitors, yes, that's another way to store energy, but a very less duration. But in general, if you look at it, it's going to be battery, flywheel, pumped hydro, and then the gravity energy storage system. So these are the four common methods we use for storage. As you said, capacitors can give a very short duration in electronics, agreed, and supercapacitors can give for certain duration. And the other popular method was flywheel because motor can also be a generator. So there are flywheels or dead weights that you can add and try to store energy on it. And you will get online UPS uses this technology. That is the way we are doing it. And the very common method is pumped hydro. I think a lot of places pumped hydro storage is very, very common. And it is also cheaper when compared to other methods. If you look at the cost of energy, levelized cost of energy or levelized cost of storage for that matter, pumped hydro will lead the thing. And then battery is becoming popular of late. In the last decade also, battery has advanced in many ways, and we are able to reduce the cost significantly. So battery, no doubt, is the number one technology today. But what is going to happen with the battery is one, it is a chemical thing. And then how do you dispose the battery? Of course, you have rechargeable battery. You can use it for like 7 years to 10 years. And I'm sure technology will take it to further years, like 15 years or something. But it is not safe. It involves chemical. And second thing is, you should also take care of the safety. It's highly explosive as well. So when the scale is large, it's going to be explosive as well. But nevertheless, it is advancing in a big way in the globe, and battery is leading at this point in time. So that's when Energy Vault is a company which has come out with something called gravity energy storage. So if this technology is proven, it's already proven at a technology level, but at a commercial level, it is being tried out in China and US. And if that comes in, we will have a long-term solution for a energy storage. So that's how I see it. And in today's session, we will talk about what is gravity energy storage. Any idea? Anyone knows about gravity energy storage? At least I would like to get one or two responses. All right. Uh, so just as a continuity, I'm saying battery energy storage is going to look like something like that. And Energy World is a company which is already deploying a lot of battery energy storage solution. You could see the size, it goes up to 1 acre, 1.5 acres, where you spread across the battery and the enclosures. With the battery management software, BMS is what we call. We develop the software and we manage the power supply to the grid as well. So this is the battery B Vault. We call it as a B Vault. And then we will jump on to GVault, which is the long duration gravity energy storage. This is one of its kind. Anyone has heard about this company called Energy Vault? Can say yes or no. That would help me to move forward.
We have not heard of it, but the gravity actually you can gain potential of any object, potential energy in any object if you move at above the ground, at a height above the ground.
Excellent, sir. That's fantastic. I think that's exactly the technology that Energy Vault is using. There are also companies which does it underground as well. The mining, they put a shaft, and then whatever they are doing in the gravity, they do it at a zero level from the ground to the mine as well. So both ways are possible. A lot of R&D is going on both sides, and we will talk about gravity now. So this is one of the commercial site that Energy Vault is building in China. It's a public information. You can Google it. You will get to see this. You can see a big structure. This is only a civil structure to store the energy. As Sir has said rightly, when you take certain mass to a certain height, it gains the potential energy. That is the ultimate principle it involves. It's a very basic phenomenal thing, but somebody has to really think about it, and convert that thinking into reality. That is what Energy Vault has done it. If you want to know about the height of this building, it is somewhere around 120 meters in height, 240 meters in height. If somebody want to visualize it, if you are living in an apartment, it's somewhere around 45-story building. So if you are on a 45th floor, you can imagine at what height you are in. So that is the principle that they wanted to use it. And the actual implementation, and the one that you are seeing is 25 megawatt of power you can store and discharge it for 4 hours. Thereby you get 100 megawatt hour of power. So, or energy. So that is the first project that Energy Vault is involved with China. And then it's a public information again. It's available in the Energy Vault website, or if you put a gravity energy storage, YouTube is going to get you this video. I'll play this video and then we can continue the discussion. Just let me know whether the audio is audible.
Audio is not coming, sir.
Audio is not coming?
Yes, sir. Yes, sir. Actually, we have to share while sharing, it will ask, sir, with audio or not, like that. We have to enable that with the audio options.
Let me see that. I have. Let me go to Teams. Yeah, I have. Should I put it on laptop?
Yes, sir.
So can change it to speaker. Right now it is in my monitor, so I'll just change it. Let's see.
Actually, you stop sharing, sir. While sharing, it will come, sir. First, you have to. While
I'm sharing my entire screen.
Okay, sir. No, sir. While sharing, it will ask, sir, that with the audio one.
Okay. I'm seeing that. I'm seeing that. There is something called share sound that's not getting enabled.
Actually, sir, you stop sharing, sir. Once again, you go to Teams. If you click share button, below that, share content input sound is there.
Okay, I'm in Teams.
Yes, sir. You just click a share button, sir.
Okay.
Below that share content include sound is there, no, sir? First option. It's coming or not, sir? If you click that share, then below that first option, share content include sound.
Include, yes.
Yes, sir.
But that's not getting enabled for me. Include sound is coming, switch is coming.
Okay, okay.
Speaker, okay. Let me do this. Audio setting. Speakers not. Speaker. It will not.
Sir, you are sharing the entire screen, right?
Right.
In that, there is a share. Also, the audio option is there.
Try this. Can you hear me?
Yes.
Is the audio audible?
No, sir. No, sir.
Okay, I'm not sure. Someone wants to play this video?
Okay, sir. You send to us, sir. We will try, sir.
Just Google.
Google.
Let me see this. Let me know whether it is audible to you. Is it audible for you?
Energy Vault develops gravity energy storage
Oh, it's coming, sir. Now it's coming.
Okay.
solutions and energy management software to accelerate the global. Energy Vault develops gravity energy storage solutions and energy management software to accelerate the global transition to renewable energy. The Energy Vault Resiliency Center is designed to improve grid resiliency and dispatch energy at the optimal time. So how does Energy Vault gravity energy storage work? Energy Vault gravity-based solutions employ a proprietary mechanical process and energy management system to store and discharge electricity. When renewable energy generation is high, EVRC uses that energy to raise 30-ton bricks to an elevated position. Potential energy is stored in the elevation gain of the brick. When energy is needed, EVRC releases kinetic energy back to the grid via controlled lowering of the bricks under gravitational force. EVX is the modular building brick of the EVRC system that can be built to scale in increments of 10 megawatt-hour units. To fulfill energy demand, to support grid resiliency, and to manage energy-disruptive climate events and extreme weather. The systems can be co-located with renewables and/or built as standalone storage to support grid stability, designed to meet standard building codes and constructed utilizing local labor and recycled materials. Energy Vault, gravity-based energy storage are designed to power our lives and to enable a renewable world.
Okay, so we will keep this video in case if you need to come back, we can always come back here. So have anyone have grasped the complete content of it?
To an extent, we could understand actually.
Okay.
I hope so. There are many cells of which can be used for lifting the bricks. Am I right?
Yeah. Can you repeat it? Sorry. Yeah.
There are many cells in the sense which is actually having bricks of some 10 tons or something, which is
Right.
lifted during the excess production of power, and it is stored as a energy which is at the high potential. But when we
Excellent.
require, it can be brought down. So as it moves down, it transforms into kinetic energy, which can be converted into the electrical energy.
Excellent,
Is
sir.
it? I hope, but there are many questions for me. Only when you
Okay.
explain, because you are on the practical this thing side, you should explain me more.
Sure, absolutely. I think I'm very glad that you could exactly pinpoint the technology. I think what you said is exactly what we are doing as well. So what I will do is I'll just go through the structure, and then you can ask questions in case if that's not clear to you. So that way it will be a two-way communication as well. Okay, so I'll move on to the next slide. The principle is same. So if you look at the basic components of the gravity energy storage, there are about 4 or 5 components, but I will let you know. When you have all the bricks, like you said cells, so all the bricks, if it is at 100 meters height, it is as per our design. The height could be different, but the energy would come down. So if you see here, all of them are stored at a height. When all the bricks are at an height, it is called a charged state. That is the first thing that you should understand. And as you rightly said, whenever there is a demand for higher energy and there is a grid capacity is less, you can, discharge the charge by bringing the bricks from top to the bottom. Whenever it comes from top to the bottom, it releases the energy to the grid. When I say it releases the energy, whatever you said, the potential energy is converted to kinetic energy. Kinetic energy is converted to mechanical energy, and then mechanical energy is converted to electrical energy. So that is the principle. So I want you to understand, when it is at the top, it is charged. When it is at the bottom, it is discharged. Like a battery, you have certain voltage when it is charged. You have a certain voltage which is lesser than where it can deliver power. That is called discharge state. So that is the first analogy that you should understand. Second, since it is working on the gravity principle, and we are going to use the mass to generate the energy, higher the mass, it is better for our energy. So if I have, and each of the brick is weighing somewhere around 25 to 30 tons, or 25 to 27 tons, which means for 100 megawatt hour capacity, I need 12,000 such blocks. You can imagine 12,000 into 30 tons. So that is the amount of weight that we will take it to the higher level, which means I need a strong foundation. So the number one item required for gravity energy storage is strong foundation. It should carry enormous weight. That is the first component. The second component is the weight has to come to the foundation, but that you need a structure to support it. We call that as a fixed frame that you could see here. So this is the fixed frame that you are seeing. That is the second subcomponent. And the third one is, I think the mass is critical for us. The third subsystem is mobile mass. We call it as mobile mass or brick. So you can call it either ways. And these are the three major subsystems. And then we call the entire assembly as a, or subassembly as a lifting system. It has multiple subcomponents. If you have watched the video, you could have heard about a horizontal trolley. The reason for horizontal trolley is you have number of bricks here. and the bricks have to be brought down only at the end. Either it can come through this or it can come through this, depending upon the architecture. And we will not have only one. The entire thing that you are seeing is called a slice. We will have multiple slices, which means one slice, if we are taking the brick on the right direction, on the next slice, we will take the brick on the left, so that the whole mechanism becomes much simpler. So in order to bring the brick from its current position to the end position, we need something called horizontal trolley. That's this particular system, subsystem number 1. Then, okay, I have a brick here, but who will take the brick all the way from top to the down, right? So you could see a yellow color thing over here. So that's called the elevator, or the cage, or the lift. That's what we call it as. So that is the other subsystem that you are mentioning here. Then we have the power supply and control box, obviously to control the trolley and the elevator. And then we need something called a motor generator. That would be placed at the bottom. In the video, we have shown on the top, but practically it becomes challenging for us to maintain. Therefore, we have shifted it to the ground. That is where we will put the motor generator drive here. And the whole thing will be coupled. You need a pulley. For example, if the mass is going down, we need to control it. So we will have a rope tied in here, and there is a subsystem called up cursor that will go down, comes all the way down to the generator shaft, and then goes back to the counterweight. So I know how many of you can imagine. So you have a brick, you have a cage. So the cage takes this and goes down. That is tied to a rope through a pulley, which is called up cursor, and then comes down to the generator and then to the counterweight. So this is the whole mechanism, and these are the components. I will pause here. Do you have any questions on this? Anyone not understand the subsystems? I can clarify.
Actually, we are transferring the energy from electrical to the what do you call it as mechanical movement, and again we are moving back. In the sense, we are converting it as kinetic energy and transforming it to the electrical energy via mechanical movement. What my question is actually, it involves a lot of transformation of energy.
Correct.
So in each transformation of energy, there will be almost, we can assume, some 10% loss. So in that case, how far we will be successful enough, if it is not renewable, in the sense if it is some other form of energy which is not freely available, the cost of conversion and reconversion will be huge enough.
Right.
So how we are going to face those things? If it is renewable, it's okay. It's an open energy. So anyhow, we are going to store some loss can be acceptable. But if it is something like costly energy like thermal or some other energy, or sometimes even seasonal energies like wind, so how we can compensate for the loss? Or is there you are researching upon further?
Okay, so I would answer this in two aspects. One is, have you heard about something called RTE? RTE?
No, sir. Please explain.
Okay, that is my last slide, so I will explain that. There is something called round trip efficiency. Okay, so for a battery energy storage system, the round trip efficiency is around 92%. Which means if you have a battery and you put a charge, say it takes about 100 watts, 92 watts, you get it out. So 8% is a loss. This includes charging current, and this includes your load, everything. That's why it's called round trip efficiency. If you look at some of the other like pumped hydro systems, the round trip efficiency is somewhere around 70%, 65 to 70%. The flywheel is somewhere around 60% because the mass has to rotate. There are a lot of mechanical losses, as you explained. It is significantly lower. But on the gravity energy storage system, we claim up to 85% round trip efficiency. It could vary anywhere between 85 to 87% is what we are claiming. So then the obvious question is, if the battery is having 92%, why should I accept a system which has a lesser round trip efficiency than battery, which is around 85 to 87? Is that correct?
Yeah, the question actually you have put it in nice way. In the sense, my understanding is if it is battery, I can't claim it to be environmental friendly, whereas
Right.
gravitational, it's absolutely an environmental friendly.
Right.
That is the only way which we can project the things.
Yeah,
I hope so.
that is one aspect. And the second aspect is the 92% efficiency of the battery is only for the first year. As you keep consuming the battery, the round trip efficiency of the battery for the second year, third year, fourth year will come down by 2.5 to 3% on a year-over-year basis. So 92 will come down to
the
87.
state of health will be down.
Right. So in a sense, truly it's not 92%. I don't know if you take an average, it could still be 87, 86% for a battery life of say 5 to 6 years or 7 years, right? So one aspect is round trip efficiency. And so I think I answered a portion of 50% of your question. Okay. And the second thing is the whole thing is managed through an architecture called regenerative power. So I am not the expert on the regenerative power, but what we also do is whenever the brick is put down and then taken it up, we also use the regenerative power. That's why we were able to meet 87% round trip efficiency. This is one portion of the question. And the second portion to address is, you said renewable is okay because wind is coming seasonal, or solar is there, excess, you are utilizing it. It doesn't stop there alone. If you take a thermal power plant, you could have a capacity of 500 megawatt or 800 megawatt or 300 megawatt of power generation. But are you running the plant at an efficiency of 90% with a load utilization? If you ask me, it's not truly right, because there are times where you utilize the plant to the fullest capacity, but there are times where it is running at a very lightly loaded condition, which means again you are wasting your energy there or power there. So you can use the excess power of the thermal power plant as well to lift the brick from ground to the top. So not necessarily a renewable energy. Your conventional energy, if it is produced in excess, to improve the capacity utilization, you can use the thermal power plant as well to lift the blocks. Does it make sense?
Yeah, absolutely, it makes sense. But the thing is, the cost of that energy storage and recovery.
Right. So anything that you start, the cost is going to be higher. I would like you guys to think of a camera when the digital camera came in, or when the mobile came in. So we paid a huge amount of money for the initial period, but now if you look at it, the technology has advanced and everybody has a camera or the mobile phones. So that has brought down the cost significantly, while the feature has added dramatically, therefore the cost has gone higher again. So yes, you are absolutely right. The cost of energy of the gravity energy storage is not on par with batteries. We are maybe 1.5%. I'm not allowed to tell, but then approximately around somewhere in the ballpark number of 1.2, 1.5 times. So we are slightly expensive at this point in time, but this is only a beginning. As we prove the technology commercially and with the volume and scale and the supply chain, the cost can be brought down significantly. And the subsequent slide will talk about it. If you take a battery, the life is only for 7 years. after that, or 10 years, then you need to replace it. But with the gravity energy storage in place, which is made up of mostly the civil engineering, concrete structures and things like that, the useful life could be beyond 30 years, but Energy World claims it to be 25 to 30 years. So it's really a long life product, and then the initial investment, what it takes, can be amortized over 30 years rather than 7 years or 10 years. So cost is higher, agreed, but on a longer term basis, it will become competitive.
Is there any idea of the recovery of investment?
Yes, absolutely. Because any investors who wants to do this, obviously they're not going to come and invest it if there is no return on investment. So business case has been made, and you can get the money back in like over 30 years. It's going to be very competitive. But at this point in time, because of the scale, the cost is higher. But if you go with 1 gigawatt or 2 gigawatt or 3 gigawatt, then obviously the volume kicks in, and then the cost can be brought down significantly. Just to give an example, the horizontal trolley, what I talked about, or the number of mobile masses for 100 megawatt hour systems, the mobile mass is around 12,000 numbers. The horizontal trolley is about 750 trolleys we need. This is only 100 megawatt. You just multiply that by, say, 1 gigawatt, then the volume is phenomenal. So, but you need to have a capacity. Technology has to be proven. It's a mega scale project. It's not a small project, and it's going to be a EPC contract. So it would take time to build it, somewhere around 18 months to 36 months. So good thing is we have already started, and we will go a long way.
It is very interesting, sir, actually. But that there is a catch, I think. For example, when we use some motor or generator, is usually the efficiency comes around 85.
Okay.
That's my practical this thing finding. You may question it, but the thing is, we are apart from the electrical conversion, we will be encountering the frictional forces, which there will be some losses because of the friction, not only in the motor, it is in the movement of the tons of these bricks which you are moving, right? So that may amount to another 5%. So I have a little vagueness over your claim of 85 to 87% round trip efficiency. Am I right? My question is clear, I hope.
Yeah, your question is absolutely right. I want to bring in a couple of topics here. One is whatever you were thinking about the motor efficiency is 85%. There are different types of motor with IE1, IE2, IE3, IE4. So with the regulation kicking in, and there are countries where they don't even want IE1 motors to enter. So even in India, IE2 motors are not allowed. So if you go increasing on the regulatory stuff, I think the efficiency can hit up to 97% to 94%. So that way, that's not a big deal. And when compared to the mass that we are doing, the friction what is generated is negligible. So all those calculation has been done, and we have actually proved in China our efficiency is close to 87%. RTE, the questions, whatever you asked, these questions were asked by some of the power plant people or some of the energy storage people. And we, at that point in time, about 18 months back, we had it in theory, but now we had practically, we have measured it somewhere close to 87%. There are a few things. One is, I said, regenerative power, you need to take that into account. And the motor selections with IE4, IE3 kind of rating, cost goes higher, but your efficiency is much better. And all your friction losses due to mechanical, all those things are taken into account. So round trip efficiency is not a problem to achieve up to 87%, 86%. Okay.
Interesting, sir. Please proceed.
Yeah. I just want to show you some of the pictures, how the structure is being made. One is called the foundation, the fixed frame that we saw. So we put a structure piece, either it could be a pile structure or it could be a padding like what we are showing. This is something like a pile that goes below it, and this is a padding thing. And then we always have a tabletop. We call this as a tabletop structure. And we raise this up to 45 stories, but in this case it is 32, but it is equivalent to 45-story building because the height we adjusted. And this is the mobile mass that you could see to load it onto the fixed frame. So this is some of the pictures that we thought we'll show you, and this is the horizontal trolley that I talked about it. This is item 1 and 2 of the previous slide. And now I will show you a mobile mass. This is the mobile mass size. If you have a 10 by 10 room, you can accommodate 2 mobile masses. 10 by 10 by 10 height. So that's the size of this brick, which weighs anywhere between 25 to 32 tons. And the horizontal trolley that you see here, this is being manufactured in India, in Bangalore, and we shipped it to US. And this is the horizontal trolley. And this is the cage. This is the one that's going to take the mobile mass or the brick into it, and then going to fall from top to bottom. And this one goes and gets connected to the up cursor here. I told you, for a simple understanding, you can consider this as a pulley on the top. So through the pulley, there will be a rope that goes down and gets connected. See, you can see here 1, 2, 3, 4, I think 12 or 24, depending upon the size, that will get connected to this shaft. And this shaft is the one that is going to have the brake, clutch, motor assembly and generator. So that is how we are generating the power. When I say generating, using the stored energy. Any questions? Okay. And G-Vault, why it is proven technology. Here we claimed 80%, but actually we are at 87% efficiency, and 35 plus years of life easily you can achieve. But if you maintain it well, it could come up to 50, 60 years as well. And the circular economy is good, and the carbon footprint to, when you compare to the thermal plant and things like that, if you are able to come or switch to, say, renewables, this would be a really green energy that you will get it. And as I explained, supply chain is very important for us. And with India kind of a country, if the technology is proven, and we could get the cost out on the technology and the engineering and all other things, then India could be a major customer for energy, for gravity energy storage. And then local sourcing and construction, because it need not have to be imported anywhere, because the major cost comes from the structures. And if you have the local source of steel, or the cement or the soil or the waste to make the bricks, then the cost would come down significantly as well. Okay, so, and I think we were talking about the round trip efficiency. Just to give you an idea of round trip efficiency, I think this is what I said. It could be up to 95% with the lithium ion battery, and that segment could anywhere be here. But with Energy Vault, we could play, but the batteries can come only up to 6 hours of storage. It cannot give you a long-term storage because the size would become very, very, very big. So, but gravity can play anywhere between, say, 4 hours all the way up to probably 12 hours. So that's where the gravity energy is going to play a role. And there are, other methods like thermal storage or the N2 and things like that can flow on the other side, but the efficiency is much lower. So this is the round trip efficiency that we get it with this. And I also want to show you one more video before we wrap it up. I'll show you that video, how in reality, how you will see it. So I will show you.
recently, and now it's time to stop the script before things get out of hand. This will be short and sweet, but if you want a more detailed take.
So in reality, if somebody wants to know how this technology is going to work, it's going to be amazing. There's no sound here, so you could just watch it. So the one you can follow only one at a time. So you could see that. See, watch it here where my arrow is here. So it will come after some time, and then it's going to come and place. It is storing it now. It is collecting it from the bottom and putting it onto the top. That's what it is. This is doing. The reverse process also will happen on the other side. So these are the bricks, and this brick will come down to this first level at the bottom. Second one will come to the second one. Like that, it will come down. The yellow one that moves on the horizontal is called the horizontal trolley. The one that moves vertically, this is called the cage or the lift. And then this is the fixed frame structure. So all the bricks will be timed, and then it will be brought down, and it has to be orchestrated at a particular way so that there is no interruption of energy or power coming from the grid. And you could also see how it is taking at a minute level. So it goes in, picks the brick, comes down and goes up. In this case, it's going up. So that's another thing, and I will show you some more sequencing. You could see it. So this is the cage that's going to come in here, goes in, picks the brick, and this is the horizontal trolley. Then it goes up all the way or comes down all the way. So that's kind of the sequence that you could see here. This is the one, and then let's move on to this topic. So then what happens is we were working on this technology for the last 3-4 years, and then cost is also an important factor, as some of you have raised it. What about the cost? So we have different models. One is called the EVX, which I explained to you now, which we are building in China and in what is it called, Schneider in US. There is also the next technology, because we wanted to minimize the cost. What happens is the cost comes down significantly down if we have a slope already. So instead of this being straight, if there is a slope that is coming in, still we can push the weight on the slope. In this case, we don't need to build the complete structure, because any hilly area you have, we can use the top of the hill as the base and the bottom of the hill as your landing area. Still, the gravity can work. In this case, if you go back to the previous slide, whatever you are seeing here, we don't need to build the entire structure. The top 8 alone we will build, the bottom we don't build. You assume there is a slope of a mountain or a valley that comes in this way. The bottom, we use it to collect the bricks. So naturally, we will send it using a rope mechanism. Therefore, we can eliminate the cost of this frame. So that's how we are working on, and that has given the cost significantly down. Around 30% of the cost goes off. So we are currently doing that, and that's pretty exciting for us. And then there is also something called the Tower of Power, which we are working on. You guys know the Burj Khalifa in Dubai. So we are also working with some of the architects who have designed that. There is something called Tower of Power, which will be close to 1 kilometer tall. So we will make that thing, and you will have all commercials things running around here inside. But still it could deliver power for the entire city or something like that. So this is our wish, and I hope we will deliver this at some point in time in the future. But this is also, achievable. So these are some of the business expansion that we are thinking of. And that's pretty much the gravity energy storage solution that I wanted to present today. But I'm more than happy to take any questions.
So what is the total height of the structure?
Which structure, sir? This one?
Yeah, the previous slide that you were showing the bricks one.
Yeah.
So what is the total height?
This would be close to 120 to 140 meters, depending upon the regulations allowed in a particular country. For example, we wanted to go up to 150, but in China we could get approval only up to 120. So in China it is up to 120, but in India we pitched for 140. But that requires a separate regulatory body to approve for the height. But we need a 100-meter fall to maximize the round trip efficiency.
Okay, sir. Okay.
One more question from my side. Is there any intermediary level of storage? Do you stop that brick in between? Is there any plan, or you want the entire height to be covered in one stretch?
There is no intermediary level where the brick will stop. So when it starts from the top, it will come only to the bottom. Otherwise, the power will get interrupted. But if you're asking about can we utilize the intermediary spaces for something else, that might be possible, but we need to explore, because there were talks, can we let it out to store a container, or can we have some storage area, old record storage area, can we utilize the space whenever the load comes in, and we can collect some rentals from the building as well. So these are some of the crazy thoughts that we could get it from customers as well. So the fixed structure, the intermediary blocks could be used for something else, so that we maximize we minimize the cost of the investment. But if you're asking for the brick, nothing will stop at midpoints.
No, the thing is actually when the available power or energy is such that it can lift only half the way.
Yeah.
Can it be utilized or not? I'm not asking about when it is coming down. I'm asking about when it is lifting up.
Again, algorithm has to be built in. So what you can do is, instead of picking, because what you are seeing is only one slide. But if you, in a real thing, if you look at it, there will be multiple slices, right? So if you don't want to, you don't have time to pick up all the way till I want to put it in between. That's not allowed at this point in time. But we could control the number of slices. But you don't want to pick all 20 slices at a time, because I don't have energy. I want to pick up only 2. Yeah, you could do 2 slices. That's fine. Or 1 slice is fine. But it has to go to the top. There is no way that we can put it in between, because there's no provision made to land in the intermediary level.
Understood. Any other questions? Participants can share that in the chat.
Yeah, I know it's a fag end of the day, 7:30 to 9.
Sir,
I know it's a dinner time.
Sir. So what is the total land area required?
It's a great question. So for 100 megawatt hour of energy storage, actual land needed is only 2 to 3 acres. Okay, but I will tell you another fact that would be very interesting. To build this 100 megawatt hour, we need 2 to 3 acres, but for the space required for construction is close to 8 acres. Because everything has to be manufactured at that place and then transferred to this building. It is not possible for us to manufacture at some place and bring everything over road or any other transport, because that's going to be more expensive. So
Okay, sir. Okay.
So it's 2 to 3 acres, but you need additional space for construction as well. But after construction, you don't need the space.
Sir, have you
नॉर्मल कॉल करते भाई आवाज नहीं जाते आपला आवाज नहीं जाते थांब जरा
sir, have you worked on how much cost per megawatt hour, how much cost will come?
Yes. The current requirement for if we are to compete with the battery segment, people are asking somewhere around $400 per kilowatt hour. If we have to be competitive with the batteries, 400 to 450, but we are not there yet. We are somewhere around $600 to $650 per hour at this point in time.
Okay, thank you, sir.
All right. So if there are no other questions, I really thank every one of you who has taken time to participate in this. And it's also really refreshing for us to talk to college level people. So thank you very much.
Thank you, sir. Thank you for an informative session. Dear participants, if you have any queries, you can post it in the chat box also.
Annamalai sir, will you be able to share your mail ID so that participants, if they have any queries, they can put a word to you?
Yes. Yes, I can do that. So give me a minute. I'll just put it in the chat window immediately.
Sir, any projects in India that is using the gravity energy storage system?
Not yet. We had some discussions with major customers. The cost is the bottleneck. Once the costs come down, we will have a lot of projects.
Is the regulation allowed, sir?
Yes. Okay. Of course, we have to take some permissions, but it's doable.
Okay.
Sir, have you implemented in like a prototype kind of a thing?
Yes, we have the Energy Vault has a R&D center in Switzerland. A prototype has been made there and they have tested the technology. And I would strongly recommend every one of you to visit the Energy Vault website. There are a lot of videos around this technology. You could see that. And we are also constructing a prototype in Snyder, Texas. So it will be operational pretty soon in another 3 to 4 months as well. And the commercial project is happening in China.
Okay. Thank you.
Shall we conclude, sir?
Yes, madam.
Thank
Sure.
you, sir. Now, I request Mrs. S. Sangeeta, Assistant Professor, Department of EEE, to deliver vote of thanks.
Good evening, everyone. It's my great honor and privilege to deliver the vote of thanks as we conclude this remarkable session 4 of ATAL sponsored 6 days online FDP on recent trends and advancement in integrated power system. On behalf of our organizing committee, I would like to express our sincere gratitude to our esteemed resource person, Annamalai Ramanathan, Director, Kronos Imaging India Private Limited, for delivering such an enlightening, thought-provoking, and engaging session on gravity energy storage project. Your expertise, clarity, and enthusiasm have truly made the session insightful. Your commitment to sharing knowledge with such passion and clarity is truly commendable, and we are grateful to have had this opportunity to learn from you. Once again, thank you, sir, for your generosity, patience, and for engaging us so efficiently. We hope to have the privilege of hosting you again in the future. Thank you and wishing you all continued success. Thank you, sir.
Thank you, madam.
Thank you, sir, for engaging us with a different perspective of energy storage. Actually, we like our participants to engage in such research and come up with some more fruitful outputs. Thank you so much, sir.
So thank you, Mr. Ilampoornan and other members who has given me opportunity to present it to you in the right forum. Thank you.
Thank you, sir. Thank you, sir.
Thank you. Bye-bye.
Participants, kindly put your name as it is, as you have entered in the ATAL portal. Please do it carefully, because we are taking all the informations from your feedback, including our attendance also. Thank you.
Thank you, sir.
Madam, Jayalakshmi madam, please.
Okay, sir. Thank you, sir. Please kindly fill the feedback link. Sir, attendances are very mandatory. 80% of attendance is required. So please kindly fill the feedback link. Stop sharing.